Alright, welcome back. Been about a week or so since I did a video on the F-22. Just had to do some real life things and been out of town, birthday, that kind of stuff all kind of came through. So getting back to it, I wanted to show you guys kind of the breakdown of the hardware for each servo and the wing. This is the second wing, the first one's done. This one should go quicker just because I know how to kind of do it. But I'm trying to use as much of the stock hardware as possible. I kind of mentioned already about the L brackets. I'm using L brackets. It's so much easier. Makes it easy to get the servo in and out. And I mean, the way they designed it, you know, you'd think that that's the way they intended it, but who knows? So you can use wood blocks. I'm using the L brackets. And so for the leading edge flap, you've got you remember you keep the screws that hold the plates, the L brackets to this ply plate need to be pretty short so they don't go all the way through. Be careful when you're drilling it. I've got 2 extra washers here to put between the ball and the arm. That gives it the ability to swivel. This one's pretty nasty. I don't know. The other one, this one looks all oxidized and everything. The other one looked pretty look like brand new polished aluminum. The ball is completely seized up on this one. So I'm going to try to kind of like it's just corroded and oxidized, and it's even got some glue on it. So hopefully I can get that ball freed up in there. But anyway, so I'm using these 1/2-inch arms. I use this inside a hole on every arm. I got it for the main flaps. I'm using it same servo arm on the leading edge slat, and then I'm even using these little guys, which is an SWB long arm that I've cut down and re-drilled to the hole. So you can kind of see this is what I had. I didn't have any this long, but I'm essentially at the F for Futaba on this arm, and that's what I'm using for the aileron arm. One, it allows you to pretty much use all of your travel on the servo to keep your throws, your servo curves linear, and it helps you get the correct geometry on the servo as well. So just keep that in mind. That's just good technique in general. So for your leading edge slat or flap, whatever you call it, 4 washers and 4 3mm bolts for the bracket to hold the servo to the bracket, 2 washers to kind of give some space in between the ball and the arm, 4 screws, L brackets, and then you go to the flap. This is the longer rod that comes with the kit. I did use the rods for the flaps, 2 ball ends, 3 washers to go underneath the ball and the servo arm, 3mm with lock nut to attach the rod to the servo arm, 3mm with a lock nut to attach the ball end to the actual control surface. 4 screws, because this servo is basically mounted to a ply rib, so you attach it with screws, and that's it for the flap. The aileron, the T brackets, 4 3mm bolts with washers to hold it in, 1 washer to put underneath the ball and between the ball and the servo arm. Actually, I'm sorry, to put on the outside of the ball, just to kind of keep it if it does come off. And that's what I did for this one as well. You got 1 big washer, so if the ball fails, the plastic arm won't go past the washer. So you'll get slop, but it'll still be attached. And that's what I did here. And then 1 3mm lock nut and a washer for this one, because it's not a dual, it's a single. So you put the bolt on the washer, put the bolt in the washer through the ball end, and then attach it so that way if the ball fails or it comes off the ball, it won't go past the big washer. It needs to be bigger than the ball radius. So I used a titanium turnbuckle rod because the one they supplied is extremely short. Even with the servo on flip this way at its slowest travel, still could not make the length that required for that. So, and you need a very short servo arm as well. Plus that keeps you from rubbing the cover. If you get too large, the cover will rub. So you got to go short on the rods. So that is the equipment, and then this is what it looks like when each one's finished. So there is the setup for your aileron. You can see the washers that I put on the end to keep the ball from coming up, or the rod end to come off the ball. And then this one you can attach it. You can see the washer up there too. It's a big washer just to kind of keep it from coming off. And then there's your flap servo. Same deal. Nothing crazy. I did have to use a flat 3mm bolt versus a lock nut because the flat one was hitting the servo. It was just, or the regular lock nut was hitting the servo, so I needed a lower profile with that particular servo arm, because you can't get too crazy of a servo arm, because if the servo arm's too thick, it will hit this cross beam, this ply beam, and I don't want to go having to cut that or anything. So, and then you get down here to the leading edge flap. Let me get stand by. Let me get a flashlight. That ain't gonna work. That's actually completely worthless. Okay, so need some new batteries. So let me hold it up here. There you go. So you can see I had to put oh, that's one thing I didn't put. I've got a piece of carbon there to act as a spacer. It looks like that right there. So I forgot to add that on the video. But there's the L brackets, and when the flap is in its normal position or up position, it's pretty much in line with the servo, so all the force isn't actually, I don't know how to even say that, but anyways, so that would be up, and then 90 degrees is down. So there you go. Kind of gives you set this down here. Kind of gives you a rundown of the wings. The hardest part of the wing, I think, is the two attachment rods that the control rod is connected to. There's a bell crank in here, and then there's two little rods that go in and out on the bell crank, and they have these style clevises on them, the Sullivans with the little retainer clips, and it's such a hard, like when you attach one, it only lets it open so far, so it's hard to get to this one. So do the outside clevis first, because the gap is bigger on the one closest to the wing root, so you have more room to work with when that one's attached. If you attach this one first, there's no way to attach that one. You can't get in there with the tools you need to attach it. So this flap was glued, like I couldn't get it to move, and there's a big huge glob of glue right here that I've got it in. So I finally got it to work, but it essentially came loose from the inside of the skin. Just a big glob of glue I saw that they just got there. I don't know how. So if your flap's not wanting to work, be careful with it. You may have glue in there, and you just need to clean it up. So but that's it. It's a long-winded video, just kind of showing you each step, all the hardware you need. Like I said, this was the one thing I didn't show you on this guy. This will go essentially between the arm and the ball. Just a piece of carbon, real thin carbon fiber. Is actually one of the servo. Like if you ever see these guys, they use them on helicopters to hold the servo in. I just cut one of those in two. So or you can use washers, whatever you got. So, but I'm gonna go ahead and I gotta take the wing out and cut all that excess epoxy out. I mean, it's working fine. It moves free. I just don't need that big glob of epoxy sitting there adding extra weight for no reason. So I'm just gonna clean that up before I attach the clevises, and then I'll get each wing in, and both wings will be done, and I'll move on to the tail. So you guys take it easy, and I'll talk to you later. Gonna be a long, not doing anything this weekend except maybe going fly on Sunday. So I'll be building all weekend. So you guys take it easy.